It is November 2023, and at NASA's Jet Propulsion Laboratory in Pasadena, a small team of engineers is staring at data that makes no sense. The numbers from Voyager 1, the most distant human-made object in history, now 24 billion kilometers from Earth, are corrupted. The flight data system has begun transmitting gibberish. Random patterns. Noise. This probe has been operating continuously for 46 years. Its plutonium power source delivers just 4.2 watts, less than a refrigerator light bulb. And now it has gone silent in a way that is different from silence. It is speaking, but in a language no one can read. The team's initial reaction is a mix of confusion and concern, as they try to comprehend the extent of the problem. Every possible explanation is considered, from a simple software glitch to a more complex hardware failure. The engineers are well aware that Voyager 1 is a relic from another era, with a computer system designed in the 1960s, and code written in an assembly language that barely anyone under 50 understands anymore. As the team delves deeper into the issue, they realize that this is not a straightforward problem to solve. The communications delay of 45 hours round trip means that every command sent must wait nearly 2 days for a response. There is no manual for this specific failure, and the engineers must rely on their collective knowledge and experience to diagnose the fault. The team is led by Suzanne Dodd, the project manager, who has spent years working on the Voyager program. She assembles a team of experts, including Ed Stone, the chief scientist, and Linda Spilker, a veteran engineer who has worked on the mission since its inception. Together, they embark on a painstaking process of elimination, testing every possible scenario, and analyzing the data from every angle. The silence from Voyager 1 is deafening, and the team is racing against time to find a solution before the probe systems fail completely. The investigation is a painstaking process, with the team working tirelessly to identify the source of the problem. After months of analysis, they finally discover the culprit, a corrupted chip in the flight data system memory. The chip is responsible for storing and processing the data, and its failure has caused the gibberish transmission. The team devises a plan to reroute the code around the damaged chip, using a combination of software patches and clever engineering. The solution is tested and retested, and finally, in April 2024, the team holds its collective breath as they send the new code to Voyager 1. The wait is agonizing, but eventually, the response comes back, and the data begins to flow again. The team erupts in a mixture of relief and jubilation as the signal comes back clean, and Voyager 1 is once again transmitting valuable data. The successful repair mission is a testament to the ingenuity and dedication of the team, and it marks a significant milestone in the history of the Voyager program. Voyager 1 launched on September 5, 1977, the same year Star Wars was released, and the same year the first personal computers went on sale. It carries a golden record with greetings in 55 languages, music from Bach to Chuck Berry, and the recorded brainwaves of Andrew Yang, captured while she was thinking about falling in love with Carl Sagan. The record is a time capsule, a message from humanity to the universe, and it has become an iconic symbol of our species' curiosity and wonder. Voyager 1 flew past Jupiter in March 1979, revealing active volcanoes on Io, the first confirmed volcanic activity ever seen on a world other than Earth. It then flew past Saturn in November 1980, and onward, into the unknown. As Voyager 1 traveled deeper into space, it continued to send back valuable data, expanding our understanding of the outer solar system. In 1990, at Carl Sagan's personal request, controllers turned Voyager's camera back toward the Sun. Earth appeared as a fraction of a single pixel, a pale blue dot suspended in a sunbeam. Sagan wrote about it in a way that has not been improved upon since. The Earth is a very small stage in a vast cosmic arena. The camera was then switched off forever to save power, but Voyager 1 continued to measure the environment around it, using its suite of instruments to study the magnetic fields, plasma, and cosmic rays. Voyager 1 is now completely blind, but it is still measuring, still sending back data that helps us understand the universe. When Voyager crossed the heliopause in August 2012, the boundary where the Sun's influence ends and true interstellar space begins, theorists had been predicting what it would find for decades. Plasma density, magnetic field orientation, cosmic ray flux, all of it modeled, all of it extrapolated from indirect measurements made inside the solar system. The scientists had expected a gradual transition, a smooth curve, but what they got was a surprise. The measurements did not match the models. The plasma density in the interstellar medium near the heliopause registered at roughly 0.08 electrons per cubic centimeter. The theoretical prediction, approximately 0.002. That is not a rounding error. That is the data being 40 times higher than expected. The instrument was checked, the calibration was verified, and the anomaly was confirmed. Something in the structure of interstellar space near our solar system is different, far denser, than decades of theory had prepared anyone for. The implications are profound, and the scientists are left with more questions than answers. If the plasma is wrong, what else is wrong? Is our understanding of the interstellar medium flawed? Are there other factors at play that we have not considered? The anomaly raises fundamental questions about the nature of the universe and the laws of physics that govern it. The team is eager to continue studying the data, to learn more about this unexpected phenomenon, and to refine their understanding of the cosmos. As they delve deeper into the mystery, they are aware that they are on the cusp of a new discovery, one that could challenge our current understanding of the universe and its many secrets. The silence from Voyager 1 has been broken, but the silence of the universe remains, waiting to be explored, waiting to be understood. And so, the journey continues, into the unknown, driven by human curiosity, and the insatiable desire to explore, to discover, and to push the boundaries of our knowledge. As Voyager 1 continues to transmit its data, the magnetic field measurements reveal another surprise. The field in interstellar space near the heliopause is running parallel to the boundary, not perpendicular as every model had predicted. This is not just a minor discrepancy, it's a fundamental aspect of the interstellar medium that challenges our understanding of the solar system's interaction with the galaxy. The leading theory to explain this is that the interstellar magnetic field in our neighborhood has been sculpted by the passage of a nearby supernova shock wave, tens of thousands of years ago. Our solar system may be sitting inside the remnant bubble of a stellar explosion that we never knew happened. This raises a question: what other secrets is the universe hiding, and how can we uncover them? The cosmic ray data from Voyager 1 provides another piece of the puzzle. When the spacecraft crossed the heliopause, cosmic radiation spiked sharply and then stabilized, but the transition was clean and abrupt, rather than gradual. This suggests that the heliosphere does not dissolve softly into space, instead, it has a hard edge, more like a shell than a mist. Something we do not yet understand is maintaining that boundary, and scientists are eager to learn more. The data from Voyager 1 is like a window into the unknown, and every new discovery raises more questions. What is the nature of this boundary, and how does it affect the solar system? To understand the significance of these findings, we need to take a step back and look at what the heliosphere actually is and why it matters. For 4.5 billion years, the Sun's solar wind has blown a bubble of charged particles and magnetic field around our solar system. Inside that bubble, we are partially shielded from galactic cosmic rays, high-energy particles accelerated by supernovae across the Milky Way that would otherwise bombard the inner planets continuously. The DNA damage from unshielded cosmic ray exposure would make complex life far harder to sustain. The fact that this bubble exists, and that it has been roughly stable across the timescales required for evolution, may be one of the more underappreciated reasons life had enough time to develop on Earth. Ed Stone, the Voyager project scientist, notes that the heliosphere is a critical component of the solar system, and understanding its structure and evolution is essential for understanding the history of life on Earth. Voyager's data suggests that this bubble is not the neat sphere we assumed. Combined with data from the IBEX spacecraft and Cassini's detection of energetic neutral atoms, the picture that emerges is of an asymmetric heliosphere, elongated in the direction of the Sun's motion through the galaxy, compressed on the leading edge, extended in a comet-like tail behind. One side of our solar system may be more exposed to interstellar radiation than the other. This has significant implications for our understanding of the solar system's interaction with the galaxy and raises questions about the potential risks and consequences of this asymmetry. Suzanne Dodd, the Voyager project manager, explains that the data from Voyager 1 is helping us to refine our models of the heliosphere and its interaction with the interstellar medium, which is essential for planning future missions and understanding the potential risks to both human and robotic explorers. The instruments on Voyager 1 were designed in the 1960s and fabricated in the early 1970s. Its plasma wave science instrument can measure electron density but not the full three-dimensional structure of plasma. It has no magnetometer capable of resolving fine magnetic structure. It carries no instrument to detect complex organic molecules in the interstellar medium. What it is measuring is extraordinary, but what it cannot measure is equally important. The proposed Interstellar probe, a NASA mission concept discussed seriously since the 2010s, would send a modern spacecraft with 21st-century instruments to 1,000 astronomical units from Earth. At realistic propulsion assumptions, it would take 15 years to cross the heliopause. As of 2024, it does not exist. It has not been funded. There is currently no second Voyager, no instrument in the interstellar medium to confirm or contradict what the original probes found. We have one data point, taken with 50-year-old sensors, and it has already overturned multiple theoretical models. Linda Spilker, the Voyager deputy project scientist, notes that the data from Voyager 1 is a reminder of the importance of continued exploration and the need for new missions to build on our current understanding of the solar system and the interstellar medium. The team at JPL who spent 5 months fixing Voyager 1 in 2023 to 2024 did so without certainty that it was possible. The communications delay alone, 45 hours for a round-trip signal, meant that every diagnostic attempt required nearly 2 days of waiting. They were operating on faith that the problem was diagnosable, that the hardware was salvageable, that 46-year-old circuitry could be coaxed back to life across the greatest distance any human communication has ever crossed. They succeeded, and what they recovered was not just data, it was the only direct measurement of interstellar space that humanity has ever taken. The engineers at JPL worked tirelessly to recover the signal, using their expertise and experience to overcome the challenges of communicating with a spacecraft that is over 24.3 billion kilometers away. Their dedication and perseverance are a testament to the human spirit of exploration and discovery. Voyager 1 is expected to lose the last of its functional instruments sometime between 2025 and 2030, as its plutonium power source decays below the threshold needed to run any sensor. After that, it will travel in silence, a ghostly presence in the vast expanse of interstellar space. It will continue moving outward at 17 kilometers per second for millions of years, a reminder of human ingenuity and the boundless curiosity that drives us to explore. In approximately 40,000 years, it will make its closest approach to another star, AC plus 793888, in the constellation Camelopardalis. It will outlast every government on Earth, every language, and possibly even our species. The thought is both humbling and awe-inspiring, a reminder of the tiny but significant place that humanity occupies in the universe. As we reflect on the journey of Voyager 1, we are reminded of the power of human exploration and the importance of pushing the boundaries of our knowledge. The spacecraft has traveled farther than any human-made object, and its discoveries have challenged our understanding of the solar system and the interstellar medium. The data from Voyager 1 is a testament to the ingenuity and dedication of the scientists and engineers who designed and built the spacecraft, and who continue to operate it today. It is also a reminder of the importance of continued exploration and the need for new missions to build on our current understanding of the universe. Come back to November 2023, when the engineers at JPL were staring at corrupted data, unsure of what the future held. They did not yet know what they were about to find, but they knew that they had a responsibility to the 46 years of work that had come before them. When Voyager's signal came back clean in April 2024, what they received was not answers, it was better questions. The plasma is denser than we thought, the magnetic field runs the wrong way, and the boundary of our solar system is sharper and stranger than any model predicted. This is the condition of genuine exploration. You do not find what you expect, you find what is actually there. And what is actually there turns out to be more interesting, more complex, and more humbling than anything you planned for. The signal takes 22 hours and 35 minutes to cross the distance between Voyager 1 and the antenna that receives it. By the time you have finished watching this, the probe has already moved another 1,000,000 kilometers further from the Sun. It is still out there, still measuring, still speaking. The data from Voyager 1 is a reminder that the universe is full of mysteries waiting to be uncovered, and that the journey of discovery is never truly over. As we continue to explore and learn, we are reminded of the importance of curiosity and the need to keep pushing the boundaries of our knowledge. Thank you for watching VoidCast. The universe keeps surprising us. Subscribe, because next week, we follow the signal further. As we delve deeper into the implications of Voyager 1's extraordinary finding, we begin to unravel the complexities of the universe and our place within it. The confirmation of an impossible phenomenon has sent shockwaves throughout the scientific community, sparking intense debate and speculation. Theorists are racing to re-examine existing models and propose new explanations, while experimentalists are eager to design and conduct experiments to test these novel ideas. At the heart of this discovery lies a fundamental challenge to our understanding of the universe's underlying laws. The impossible phenomenon observed by Voyager 1 appears to defy the principles of classical physics, forcing us to reconsider the interplay between space, time, and matter. This, in turn, has far-reaching implications for our comprehension of the cosmos, from the behavior of black holes to the formation of galaxies. As scientists struggle to make sense of this enigmatic discovery, they are reminded of the profound impact that human curiosity has on the advancement of knowledge. The Voyager 1 mission, launched over 4 decades ago, was the culmination of human ingenuity and the desire to explore the unknown. The probe's relentless journey into the depths of interstellar space serves as a testament to our species' insatiable thirst for discovery and our drive to push beyond the boundaries of what is thought possible. The discovery also highlights the importance of collaboration and international cooperation in the pursuit of scientific progress. The Voyager 1 mission was a testament to the power of global cooperation, with scientists and engineers from around the world working together to design, launch, and operate the probe. Today, as researchers from diverse backgrounds and disciplines converge to study the implications of this finding, we are reminded of the critical role that teamwork and open communication play in advancing our understanding of the universe. As we continue to analyze the data transmitted by Voyager 1, we are struck by the profound beauty and simplicity of the universe. The impossible phenomenon, once thought to be the realm of science fiction, has been revealed to be an intrinsic aspect of the cosmos, waiting to be uncovered by human curiosity and ingenuity. This realization serves as a poignant reminder of the awe-inspiring complexity and majesty of the universe, and our place within it as temporary yet vital observers. The discovery has also sparked a renewed sense of wonder and excitement among the general public, inspiring a new generation of scientists, engineers, and explorers to pursue careers in STEM fields. As we gaze up at the stars, we are reminded of the infinite possibilities that lie beyond our planet and the importance of continued investment in space exploration and scientific research. By pushing the boundaries of our knowledge and understanding, we not only expand our comprehension of the universe but also drive innovation, inspire new technologies, and foster a deeper appreciation for the beauty and complexity of the cosmos. The signal from Voyager 1, now 1,000,000 kilometers further away from the Sun, continues to whisper secrets of the universe, beckoning us to follow its journey into the unknown. As we embark on this extraordinary adventure, we are reminded of the profound responsibility that comes with being the universe's most curious and capable observers. We must continue to explore, to seek, and to discover, for it is in the pursuit of knowledge and understanding that we find our true purpose and our place within the grand tapestry of existence. In the weeks and months to come, we will continue to unravel the mysteries of the impossible phenomenon, and we invite you to join us on this extraordinary journey. As we venture deeper into the unknown, we will encounter new challenges, new discoveries, and new insights that will forever change our understanding of the universe and our place within it. The signal from Voyager 1 is a reminder that the universe is full of secrets waiting to be uncovered, and that the journey of discovery is a lifelong pursuit that inspires, educates, and transforms us all.